Good morning, students. Today we are going to discuss regarding the application of biosavart. The first application is that magnetic field due to long straight conductor. Magnetic field due to long straight conductor carrying current. Okay. So already in the last class we discussed regarding the biosavart law. According to biosavart law, see. Whatever the magnetic field dB is given by how much? Mu naught by 4 pi into ideal sin theta by r square due to small element. If you integrate it, you will get the entire conductor carrying current. Okay, so the magnetic field due to any current carrying conductor at any point is how much? dB is equal to mu naught by 4 pi into ideal sin theta by r square. In this class, we are going to discuss regarding the first application of Gauss law. Okay, that is magnetic field due to long straight conductor carrying current. So, for that purpose, we consider a long straight conductor which is carrying current I. This is the long straight conductor, okay, carrying current I. Now, our intention is we are going to find the magnetic field induction at point P. We are going to find the magnetic field induction at point P due to the entire straight conductor. Okay, first we will find for a small element AB and we will apply the limits and we will find the magnetic field due to entire straight conductor. Okay, so for that purpose we took one straight conductor carrying current I. Okay, we are divided the entire long conductor into small elements. We are considering one such a small element AB whose length is dl. Now we took one point P near the long conductor, okay, which is on x-axis, okay, and from the small element AB to the center of this conductor O, whatever the distance is small element, and from small element AB whose length is dl to the point P where we are going to find the magnetic field, the distance is r bar, which is a position vector, okay, and the distance from the center O to the point P is capital R, okay. So like this, these are the considerations we took on the diagram, okay. Now what is our intention? We are going to find the magnetic field due to the current carrying conductor, okay, at point P. Now according to biosavart law, whatever the current carrying conductor, okay, due to the current carrying conductor, how much magnetic field at point P due to the small element dl? We know that dP is equal to mu naught by 4 pi into ideal sin theta by r square. Just recall the last class, okay. So dP is equal to mu naught by 4 pi ideal sin theta by r square. This is the magnetic field due to the small element carrying current I. Okay, now what is our intention? We have to find the entire magnetic field due to the long conductor. Okay, due to the long conductor. For that purpose, what we have to do? The field due to whole conductor. How can we get? By integrating this. Integration of dB we get B. Okay, within the limits minus infinity to plus infinity because it is a long conductor. Having the limits minus infinity to plus infinity, that here O is the origin. Okay, it is infinite long conductor. So we are taking minus infinity to plus infinity. Here, whatever the mu naught by 4 pi and current carrying in the infinite conductor is I. So mu naught I 4 pi are constant, isn't it? So taking that mu naught I by 4 pi value outside and integrating the remaining things. Okay, from the limits minus infinity to plus infinity, how much? Sin theta by r square into dl. Okay, sin theta dl by r square. So minus infinity to plus infinity this value. Let us consider the first equation. Let us consider this equation as first equation and this equation as second equation. Now, what we have to do? We have to find the value of sin theta r square and dl and put it in this equation and solving it, we will get at last the magnetic field induction due to the entire infinite long conductor. Okay, so for that purpose, from the diagram. Let us observe the diagram clearly. Okay, let us observe the diagram clearly. From this diagram, the position R bar, the position vector R bar. Okay, it is right angle. See, it is right angle triangle. Let us consider OAP. OAP is a right angle triangle. So here the distance from O to A is small n and O to P is capital R, from A to P is small r. So from this right angle triangle, R square is equal to hypotenuse square is equal to opposite square to adjacent square. L square plus R square, isn't it? So from this diagram, R square is equal to L square plus capital R square. So let us just send this square this side. Become 1 by 2. So from figure, small r is equal to how much? L square plus capital R square whole power 1 by 2, isn't it? And what about sin theta? From the diagram, if you observe, this is the angle made by the remaining conductor to the small element dl. This is the angle. So sin theta. From this, if you take this angle, what about this? The entire thing is what? Pi. So this angle will become what? Pi minus theta. This angle will become what? Pi minus theta. Now sin of pi minus theta. Sin theta is equal to, this is the sin theta. Opposite is what? This. For this angle, opposite side is this. OP. So that is R. Sin theta opposite by hypotenuse. So capital R by small r. So sin theta is equal to, we know that sin of pi minus theta is how much? Sin of pi minus theta is sin theta. So sin theta is equal to sin of pi minus theta, which is equal to, from the diagram, opposite capital R by hypotenuse is small r. So capital R by small r. So sin theta is equal to capital R by small r. Simple. Now, what about sin theta? We know that R value, x square plus R square over power 1 by 2. So sin theta is equal to R by small r is nothing but what? X square plus R square over power 1 by 2. Now, substitute small r and sin theta, small r value and sin theta in equation 2. We know that sin theta value and R square value, we know this. So substitute these values in this equation. Now what happens here? Let us come to here. B is equal to, now entire magnitude will become mu naught I by 4 pi from minus infinity to plus infinity. We know that sin theta is a capital R by small r. So small r, already we have R square. So small r into R square, R cube, isn't it? So R cube. Now what is the value of R cube? We know that R value is L square plus R square whole power 1 by 2. Whole cube is nothing but what? 3 by 2. So L square plus R square whole power 3 by 2. Entirely it becomes what? R into dl by R cube is nothing but what? L square plus R square whole power 3 by 2. Isn't it? So this is what. Now for further calculations, we will consider some what we can say equations to solve this integration equation. So to simplify this equation, we consider small l. In place of small l, we took R tan alpha. See, these are the considerations we made in this derivation. So these are the considerations we are assuming for simplicity. To solve this equation, for simplicity, we are considering small l is equal to R tan alpha and derivative. What happens? dl is equal to, what is the derivation of tan alpha? Secant square alpha into d alpha. So R is constant. So tan, what we can say, differentiation of tan alpha is secant square alpha into integral, what we can say, internal derivative is d alpha. So dl is equal to R secant square alpha d alpha. We are considering that small l is equal to R tan alpha. Now differentiate this equation. dl is equal to R secant square alpha d alpha. Now the limits also changes from minus infinity to plus infinity. So the limit changes from minus pi by 2 to plus pi by 2. Okay, because as minus, so tan of minus alpha it will become minus pi by 2. Tan of alpha it will become, in place of alpha infinity, become pi by 2, because tan pi by 2 is infinity, isn't it? So like that, minus pi by 2 and plus pi by 2 then are the new limits. Okay, so simple. Just we are replacing small l by R tan alpha. It is our consideration. you differentiate it, you get r secant square alpha d alpha, and the limits will be changed to minus pi by 2 to plus pi by 2. Now the equation will becomes b is equal to mu naught I by 4 pi minus pi by 2 to plus pi by 2 because limits are changed, and we know that here we have r, but what about dl? Because L is equal to this much, dl is equal to r secant square alpha d alpha. So just replace this dl value, by r secant square alpha d alpha. So r into r secant square alpha d alpha divided by, now in place of L square, what is L? R tan alpha. Now L square becomes r square tan square alpha. Simple, r square tan square alpha plus, now r square is same. R square is same, 4 power 3 by 2. Okay, up to here clear. Now mu naught I by 4 pi minus pi by 2 plus pi by 2 same limits r into r square secant square d alpha. Here r square and r square are there. Just take common from the bracket. See, take common from the bracket. Nothing but what r square taken outside. R square whole power 3 by 2. Take outside, what happens? R square 1 by 2 will be cancelled, you get r cube, isn't it? So by bringing this r square outside the bracket, it will become r cube. Now remaining is what? 1 plus tan square alpha, 1 plus tan square alpha whole power 3 by 2. So like this, here r square, and in the denominator we have r cube, r square r cube will cancel, we get only 1 r, and secant square alpha here 1 plus tan square alpha is how much? We know that the identity secant square theta minus tan square theta is how much? Secant square theta minus tan square theta, how much is equal to 1? So secant square theta becomes what? 1 plus tan square theta. Similarly 1 plus tan square alpha is nothing but what? Secant square alpha. Okay, so 1 plus tan square alpha is nothing but what? Secant square alpha according to the identities of trigonometry. So it will become secant square alpha. Now secant square alpha whole power 3 by 2 will become what? Secant square alpha whole power 3 by 2. 2 gets cancelled, you get secant cube. Okay, secant cube. Now this secant cube and secant square alpha. See, secant square alpha, secant cube. Okay, cancel out. Only you get secant alpha. 1 of the secant alpha remains. Okay, 1 of the secant square. I think it will not be full here. So here in the numerator secant square alpha, in the denominator, because 1 plus tan square alpha, secant square alpha whole power to cancel, secant cube we will have. Okay, now secant square and cube will cancel, only 1 secant alpha will remain in the denominator, so that will be taken as same, and r square alpha cancel only r. So in the numerator we have d alpha, and in the denominator we have r secant alpha. Simple. Whereas mu naught I by 4 is constant. Okay, so we took outside, and here now if you observe here r also constant. Now bring capital R outside, mu naught I by 4 pi r. Now integration of d alpha by secant alpha, r is common. Okay, what about 1 by secant alpha? According to the trigonometric ratios, cos alpha is equal to 1 by secant alpha. So 1 by secant alpha is nothing but what? Cos alpha. So cos alpha d alpha. Okay, so integration minus pi by 2 to plus pi by 2, we will get what? Cos alpha into d alpha, because 1 by secant alpha is cos alpha. So r will be taken outside, mu naught I by 4 pi r, integration minus pi by 2 to plus pi by 2, cos alpha d alpha. Now what is integration of cos theta? Simple, it is sin theta. Integration of cos alpha is what? Sin alpha, within the limits minus pi by 2 to plus pi by 2. Okay, now apply the limits. Sin pi by 2 is 1, minus sin of minus pi by 2 is sin of minus theta is minus sin theta. Okay, sin of minus alpha or sin of minus pi by 2 is what? Minus sin pi by 2. Already here we have one minus. Okay, in the formula sin upper limit sin theta minus nothing but sin pi by 2 minus sin of minus pi by 2. But sin of minus pi by 2 is minus sin pi by 2. So minus half minus plus, you will get what? Sin sin pi by 2, sin 90 is what? 1. And sin, again minus or minus plus, so again sin pi by 2 is what? 1. So 1 plus 1, you get 1 plus 1, that is 2. That is 2 here. So 2 numerator and denominator 4. 2 ones are 2 twos are. You get at last you get how much? 2 pi r. So at last you get the entire magnetic field B is equal to mu naught I by 2 pi r Weber per meter square r Tesla. So mu naught I by 4 pi r important. This application is important. Already in the last year he asked that. So state and to Biot Savart's law and apply it for long straight conductor. So this is the long answer question, 15 marks. Okay. So he will ask both state and to Biot Savart's law and apply it for magnetic field due to long conductor or for circular loop or for solenoid. Like that we have 3 applications. He may ask this conductor, straight conductor or circular loop or solenoid. So these are the applications. So at last we will get B is equal to mu naught I by 2 pi r. This is the expression for magnetic field due to long conductor carrying current by applying Biot Savart law. Simple. Okay, this is the calculation. If you does not understand this derivation, once again see the video, repeat the video again and again. Compulsory will understand. I will send the notes, whatever the notes we derived today. Okay, thank you one and all. Okay, we will meet in the next class.